Section 3.2 continued here. We got two more objectives that are supported by pages 214 to 223. We're going to deal with residuals and how to construct residual plots for linear regression. So before we get into it, just like what the pattern we've been dealing with so far, we want to define a residual. Residual is the difference between an observed value and the predicted value. So the residual is your observed minus predicted, or we might even say actual minus predicted. So what that looks like, we have our graph that we've seen several times here, non-exercise activity in calories, fat gain. So what we're saying is that, for example, at 400 non-exercise activities, our predicted value, our y hat, because that's our predicted, we'll say 2.1 kilograms. But the actual is at, we'll say 3.8 kilograms. So then what we would do for our residual would say, okay, actual minus predicted is our residual. We would do that for all of these points and plot them. We keep our x here, but now we'll graph our residuals. So in that particular case, we had 400, the residual of negative 1.7, which is right here. Now, I rounded a little bit, that's why it doesn't quite match up. Now, residual plots, that's what we just looked at. We looked at a residual plot. The residuals was the actual calculation of the numbers. Residual plot is what we just did here. Residual plot's a scatter plot of our regression model. We have our explanatory variable, and we plot it against the difference. And the residual plot, what it does is it allows us to see how good our regression line is. Now, in this particular case, well, actually, whenever there's a residual plot graphed, we always have a horizontal line through 0. Because if our line was perfect, there wouldn't be a difference. Now, if you notice, the data follows kind of a nice linear pattern along this horizontal line. They're not perfect, but it follows a nice clear pattern of a linear, horizontal linear pattern here. That means the least squares regression line is good. We like it. Now, if you notice, on this one, you've got data that follows here, comes up and back down. There's a little bit of a curve here. There's a curve. That means our least squares regression line is bad. We don't like that least squares regression line. Here's another example. This is kind of an example of extrapolation. Here, our least squares regression line seems to fit the data pretty well. Then as we look at this portion of it, it starts to get scattered farther and farther apart. So here, the least squares regression line is not necessarily good.